Welcome back to part 2 of the burning candle saga. This is the opinionated science educator here, making videos to support grade 10 physical science learners. The question we looked at last time was, why is a candle burning considered a chemical change? And I think we firmly established in the last video that a burning candle was in fact a chemical change. You saw in a video clip that as the candle wax runs out, the candle no longer has any fuel to burn, and so the candle will eventually burn out when all the wax or fuel is used up. You also saw that if a candle is placed in a jar, once all the oxygen is used up, then the candle also stops burning. So without oxygen, the candle cannot burn. I identified the problem of students struggling to classify a burning candle as a chemical reaction when I gave them this worksheet with this cartoon. Now, the question asked them to identify the type of change that was occurring and whether it was a chemical reaction or not, giving reasons. And many of the students thought that the candle burning was a physical change, with some thinking it was a chemical change. And despite me talking about the candle wax disappearing, it took some convincing to realize that this was a chemical change. Based on this confusion, I obviously asked a couple of questions, and I'd like you to think about these questions too when you look at that candle burning. So are you thinking about the liquid that forms there? Where does that liquid come from? Does all that liquid wax solidify there? And does it look like the same amount of wax that has disappeared? So what has happened to the rest of the wax? Where has it gone? And what does the heat and light produced tell us about this change? So now, hopefully you can see the unlit and the lit candle. Now, I think the reason that this is confusing is because as you look there, you can see that the solid candle wax has become a liquid. But at the same time, there is a flame, which is an indication, at least, or a clue that this could possibly be a chemical change. So which is it? As the candle burns, the wax melts, which is the physical change, and then that melted wax is what is involved in the chemical change. I will explain both of these to you now. Okay, so there is a candle, and the candle is burning. So the candle wax is the fuel for the fire. We know that oxygen gas in the air is needed for combustion to take place, and you will either use a match or a lighter to light the wick as the candle burns. So as the candle is burning, let's take a closer look at what is happening where the fire is happening. So the solid candle wax, and there where the fire is, we have liquid candle wax. So the heat from the flame is providing the energy for the solid candle wax to melt and become liquid candle wax. Yes, that is a physical change, but that's not the candle burning. That is the wax of the candle melting. Now let's look at the chemical change. Again, a closer look, but this time we're going to try to look at the particles. So there is the molecule of paraffin wax. As you can see, it's a hydrocarbon. That is the fuel. There are carbons and hydrogens only. So it is a hydrocarbon. The oxygen is in the air. So the oxygen needed for the burning or for the combustion to take place comes from the air. And the heat from the flame provides the initial energy for that liquid candle wax in that magnified section to burn. And as a result, carbon dioxide and water are formed as products. So this is the chemical change that is taking place, the candle burning. So thank you for joining me for this short support video in which I explain why candle burning is a chemical change. But I've also explained the physical change that needs to take place so that the candle can burn and give us the heat and light that we need when Eskom decides it's time for another round of load shedding. If you haven't yet hit the subscribe button, I suggest you do so. Thank you for joining me. Until next time.